So try to use the tools that we are going to cover today on that second homework as well, and hopefully it would be a little easier. One other thing, the homework that was due right now at 11 a.m. Some students had other commitments, so it got a little late for them. So I have extended the deadline till 11 p.m. tonight. So if any of you could not submit, you have time, 12 more hours to get the work in. Any questions? Okay, so let's get going. So today we are going to wrap up vector operations, which, as I have been telling you, is the bread and butter of how MATLAB works. It deals with arrays of numbers, and by end of the lecture today, we hopefully would know most of the array operations, the vector operations that uh, typically you would come across. And from next week onward, we are going to actually focus on writing codes to solve more complicated problems. Okay, so let's get going. By the way, yesterday I had a very rough time with Zoom, and people could not hear me. So if any of you has difficulty hearing me, just shout out, and I'll try to reset the audio on my computer. Okay, so vector operations continued with where we left off on Tuesday. So again, you guys can pull up MATLAB on your computers and just type out the commands after me. So we are again going to start with the same A matrix that we had in the previous lecture. So before that, let me clear my workspace. And the way we do that is clear all. So as you can see on the top right of the screen on the MATLAB window, everything got removed. And let's do CLC, which would clean up the command window as well. Let's introduce the matrix A again. A is 1, 2, 3. Again, you enter each row at a time. 4, 5, 6, 7, 8, 9. So here we have A. Now in the last lecture, we learned how to capture a certain range of rows or a certain range of columns. So to do a very brief recap, so if I'm trying to capture the first two rows, we can as well write it as like this. So first row to the second row, and then if we are trying to capture all the columns, then I do just a colon. So hopefully it should give us the first row and the second row, but all the columns. So there we go. Now, I think I had at least one question over email that what if the matrix that you started out with, if it changes? It won't change with operations like this. And you can check that very easily by, again, typing in A and pressing the enter. But if you do something like this, which is A 1 to 2, comma, and then a colon, then your A matrix has been changed forever on this workspace. So whatever variable name you might assign to this kind of changes. So for example, if I had assigned this to be a new B matrix, then you can have that modified version of A being stored in that B matrix. So when you do your homework problems or when you solve the questions on your test, typically try to make sure that you use new variable names at each step, and you don't want to lose out on the original matrix that you started out with, unless the question actually asks you to do that. So yeah, so just having a command like this won't change A, as long as you don't assign it back to A, like I did over here. Okay, so let's reassign what I need for A today. And let's look at a few other things that you can do on A. And this is something which is new, and we did not cover it in the last lecture. So pay attention to what I'm doing now. So let's initiate a new matrix C. And okay, let's clear the window first. CLC, and A is this. So the question now is, let's pick the first row and the third row, and skip out the second row, and let's pick all the columns. So how do we do that? So the question again is, let's write down the question. Extract only the first and the third row in A and include all the columns. So we do that by this. So C is a new matrix, which would be that modified version of A. So A, so first and third row. So if we do this, it won't really work because it's going to pick all the three rows of A. So what we are going to do is something else. So square bracket open, 1, the first row, that the row number that you are going to extract, which is 1 here for the first row, and then you are going to extract the third row, so 3 for that. So just first row, third row, then comma, and since we are trying to extract all the columns, we use that colon sign, and then we press enter. So now you see that we have managed to extract the first and third row. So this technique of explicitly mentioning the row numbers or the column numbers might come in handy when you are trying to pick out some rows or some columns which are like separated from each other, and you want to skip out the in between, the intermediate rows or columns. So let's look at another example where we extract all rows, but just first and third columns. So this would be D is A. Now we are extracting all the rows, so colon for that, but just the first and third column. So 1 for the first column, 3 for the third column. So this should typically give us 147 and 369. And that's what we have here. So this is a very useful trick which we are going to use in some more problems today. Any question? Okay, so let's look at a few more examples. So let's first try to introduce into MATLAB this big Q matrix. So Q is, and please do type with me, 2, 3, 6, 0, 5, 0, 0, 20, minus 4, 3, semicolon, 1, 2, 3, 9, 8, semicolon, 2, minus 5, 5, minus 5, 6, 5, 10, 15, 20, 25. So we have this matrix. Now sometimes, and it happens particularly during the tests when you are like not really concentrating as much on this individual details, you might probably miss one particular entry over here, and that would give you an error. For example, if we had actually done something like this, where let it be a different matrix XX, and suppose we forgot to enter this 8 over here, just a typo. So what would happen then? It would say that the dimensions of the arrays are not consistent. So make sure that all the rows have the same number of columns and all the columns have the same number of rows, either way. So anyways, so we have Q now. The question is extract the second, fourth, and fifth rows and all the columns in Q and store them into a new matrix. So how do we do that? Of course, we can use the trick that we just learned, but let's make it a little more user-friendly. So here we are talking about the second entry, the fourth entry, and the fifth entry, right? So let's introduce a new vector, which is, let's call it A. And let's assign the specific numbers that we are trying to extract. So let's not think about whether we are trying to extract rows or columns as yet, because you would see that this A vector that I'm generating would be useful in either way. So second row, or the number 2, the number 4, and the number 5, which are the place numbers for either the row or the column. So this is our row vector. Now the next thing that we are going to do is actually address this question, extract those rows and all the columns into a new matrix. So let the new matrix be, say, P. So the way we are going to do this is this. So we are trying to extract from Q, so Q. Now we have already stored the place numbers over here in this small matrix A, the row vector, and we need those specific rows. So let's just use A over here, and we are trying to get all the columns. So a colon for that. So ideally, if it works out right, we are supposed to get this row and these 2 rows in the new matrix. So let's see if we get that. And indeed, so it has extracted the second row and the last 2 rows, those being the place numbers for the rows. So that way you don't really enter these numbers into this command. Rather, you can introduce a new matrix into MATLAB and use that to figure out the new extracted matrix that you are developing from Q. Now, one more reason why we do it this way, because suppose if the question is now altered to this. So extract the second, fourth, fifth columns and all the rows. So what we do next is this. So let that new matrix be, say, R, and now Q. Now the question is now for all the rows. So a colon for that, but it is now trying to extract the second, fourth, and fifth columns. So those numbers are already stored in that row vector A. So we just press A. So if it works out, we should get this column and the last 2 columns. So let's see. And indeed, we do get the second column and the fourth and fifth columns. Okay. So I think I have a similar example worked out here. So if you could not follow my typing, just try to repeat these codes when you work on your own. Okay. So let's pause. Any questions until now? Okay. One quick thing. I don't know if you guys. So I got a series of emails right now. If you have anything to tell me, just you can talk on the microphone. That's fine. I won't be able to follow up with the emails right now. Anyways, so let's move ahead. Again, we are working with the same A matrix, and hopefully I have not removed it yet from the MATLAB memory, and we have not. So I still have the A. This thing that I'm going to show here can be important for short 2-point, 3-point questions, and something that you need to remember. The question is, extract all the elements of matrix A as a column vector. So the way we do that, if I redefine the B matrix as this, so the simplest way to do this is this. There might be other complicated ways to do this, all these operations. So you might come up with better solutions than what I have in these lectures, but this is just one way to do it. So if I try to extract all the elements of A, but try to arrange it in the form of a single column vector, this is how we do it. And if you carefully inspect the way the elements have been extracted, MATLAB actually went column wise. So it first extracted all the elements in the first column, so 1, 4, 7. Then it went to the second column, 2, 5, 8, and then to the third column, 3, 6, 9. So if this kind of operation is needed as part of a longer code, you need to make sure that you know what the output is going to be. Otherwise, if you are assuming that, suppose if you are by mistake assuming that MATLAB is going to pick the rows first, so would arrange it as 1, 2, 3, 4, 5, 6, 7, 8, 9, that would be wrong. And if you are trying to use this tool into that code, whatever you are going to get eventually would be a wrong answer. So you need to know what you get from this kind of short tricks on MATLAB. And MATLAB always, unless it has been special, like unless you add some special tools or special instructions, usually with the inbuilt functions, inbuilt commands, inbuilt syntaxes, MATLAB is going to pick column-wise all the elements. So this is a slight mismatch compared to how you introduce a matrix to a MATLAB, because as we know by now very well that you enter row-wise. So you enter each row information at a time. But when it tries to pick the elements, it picks the elements along the columns in their order. Okay, so let's now look at a few other things. So we know, okay, so we have this A, and I think probably it was the first homework or the second homework, I don't remember, but there is a command called size. And if I do size A, it returns the row number and the column number in that matrix. Now suppose we have a slightly different matrix. Say AA is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is what it is. It's is it a 3 by 4 matrix or a 4 by 3 matrix? Anyone?
I would say it's a 3 by 4.
Correct. So we code the row number first. So if I do a size, if I check the size of A over here, sorry, I typed it wrong. I typed the small a. So the size of caps AA, we get those numbers. The first number stands in for the row number. The second number stands in for the number of columns. Now, this thing that I'm trying to show here is how to change the size of a matrix with the same elements. And you can do that only if the matrix, if it is an m by n matrix, then you can only resize it to a form p by q where the product of mn and pq they are same. And that makes sense, right? You can only deal with those elements. So the number of elements in the new matrix would still going to be the same. So over here, we have a 3 by 4 matrix. So one option for us would be to generate a 4 by 3 matrix instead of a 3 by 4. So let's do that. And while I was trying to prepare for this lecture, I was actually doing this. So resize A 4, 3. And I got an error. Why did I get this error? I got this error because of this command, and I was being negligent. I thought that, okay, size is the command to get the initial size of A. So if I'm trying to resize it, probably the logical command would be resize, but it is not, unfortunately. It's actually reshape. If I now type reshape AA 4, 3, we get it in this form. And by the way, I think I again typed this one wrong. So this would have been, what I was trying to type is this. And we do get that error. But anyway, so the correct command to resize a matrix is reshape. And then it reorients the arrangement of the elements. Now, if you check carefully, how does it carry out that rearrangement? It again tries to pick the elements column wise. So if you look at these entries, so if you look at these entries and compare them to these entries in the original matrix, so it first picked this column 159, and then went to the next column and included that 2. So it always followed the order of elements like a snake on this column, on the columns, top to down. Okay, so keep that in mind, that whatever MATLAB would do, if you are trying to carry out this kind of operations or manipulations on the matrix entries, everything would be extracted column wise. Okay. So another quick thing that is not much very conceptual, but it's something that you should know, is how to generate a random matrix on MATLAB. And by random matrix, it implies that the entries, the elements in that matrix are not being stated by you. They're being decided randomly by MATLAB. So if I reintroduce P as a matrix here, if I type rand 4, 3, so that means I'm trying to generate a 4 by 3 matrix, 4 rows, 3 columns. But the element entries in that new matrix are going to be random and would be randomly decided by MATLAB. So if I press an enter now, I get this. Okay, quick question for you guys. What is the version of MATLAB you are using right now? I think the one that I have is 2020A, Art 2020A. Any of you has a different version of MATLAB? No one. So I'm assuming that
I have a 2020.
you have a 2020. So I'm really curious. So could you carry out this and tell me if you get the same entries or different entries for the elements?
I get the same.
You get the same. Okay, so I guess they did not change anything from 2020 to 2020A, which is the version I have. But these numbers that I copied over here, they are, I think, for the 2018 version, which is the version that I had before. So based on the version number, the entries can be different. So if you somehow see your friend's work where the entries are different with the rand command, don't get scared. It's just probably because of the version number. And maybe years down the line, if you come back to this lecture notes, there's no reason why you would, because you would know MATLAB quite well by then. But if you come back, maybe you would see new entries because the version would be different. So anyway, so this is how you generate a random matrix, and whatever I have shown here is again the use of this reshape command to come up with a differently sized matrix, but with the same number of elements. And again, it would, as you can see from the example that I wrote down, again, it is going to pick the elements top to bottom along the columns. So this two first and then this two like this. So yeah, okay. So that's it for the reshaping, resizing command matrices. Let's now look at something that would be very useful for our lectures from next class onward. This is, as I have been telling you, MATLAB works with arrays, and arrays can be built by you in a code if you are trying to do a calculation a certain number of times, and that array would control how long a calculation is going to be carried out. So typically we would do that by this kind of operation where we tell MATLAB that there is a vector. That vector has a certain range. It starts from a certain initial value. It ends at a certain final value. So initial value, final value. And we can also give an increment. So let's write this down. So if I have a new matrix, and let's, before we move forward, clear the memory. So clear all CLC A. Okay, so if I just type 0, 10, 100, the understanding is this: 0 is the initial value for A, 100 is the final value, and the value would be incremented on steps of 10. If I press enter, this is what I get. But suppose if I try to use a different increment, say 0 to 100, but let's use the increment of a very random increment, say 17, 200. So we do get the increments 0, 17, 34, 51, 68, 85, and it does not give the last one, because the last, if it had incremented 85 by 17, it is 102, which is beyond the range of the final value. So we end up getting these specific numbers or elements being assigned to this A. So all good. Now, there are a couple of more things to know over here. If you don't use the increment, if you just press 0 to 10, the default increment that MATLAB would enforce is just 1. So 0 to 100, sorry. So 0 to 100, without any increment, without any middle placeholder. If I press the enter here, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 till 100. So the default increment would be 100. A few other things. So A is, say, 0 to 5 to 35. So this is A, but we can also sometimes type it like this: square bracket 0 to 5 with an increment of 5 till 35. And you'd get the same thing. So depending on when I took, so later on you will see that I have taken a lot of screenshots of my work as I did the coding. Sometimes you might find that I have followed this syntax or this syntax. It doesn't really matter, whichever you are comfortable with using. Okay, so keep this structure in mind. It is going to be useful quite soon. Like right in this lecture, we are going to solve a problem later on. But before we go over there, let's look at what we have here. And this, I think, might come in handy for this homework too, where you have to do a lot of matrix manipulations. So let's try to see what we have here. Okay, so we have a matrix A, which is this 1, 0, 0, 0, 1, 0, and 0, 0, 1. Sorry, so since I had the semicolon here, so the output was not shown on the command window, but this is a 1, 0, 0, 0, 1, 0, 0, 0, 1. Now we are trying to append a row or a column. So let's see how we do that. Now to do this, we are again going to follow a similar kind of strategy like we used at the beginning of this lecture. We are going to introduce some new vectors to MATLAB. So let's first just focus on how to append a row. Okay. So to append a row, let's introduce a new vector, a row vector at that, and let the new vector be, say, 10, 30, 70. Okay, so this is the row vector that we have introduced. Now, suppose we're trying to generate a new matrix which has this row attached to this original matrix A. So that new matrix B is going to be A, and then a semicolon, and then this new matrix that I have introduced, the small a. Now let's think about the logic of it. So as I have said repeatedly, that the way we introduce the elements in a matrix to MATLAB is by entering each row at a time. So if I am now trying to introduce this new matrix B, I first introduce all the rows of A. This is almost equivalent to typing out all these entries that we had originally entered for A. And now the question is, let's add one more row to that new matrix. And we know that all the rows are separated by semicolon when we start a matrix, right? Just like we did here. So we enter this A, which is equivalent to adding these elements, but separated by a semicolon. So basically, I'm adding all the rows of A with all the rows of small a. So let's see if we get what we want. So hopefully we should be getting a matrix which has all these rows plus another fourth row, which is 10, 30, 70. And indeed, we do get that new fourth row. Okay, so the next question is append a column. For that, so this is the A matrix that we are working with. I want to add a new column, a new fourth column. So let that column be, say, B. So I'm trying to add a new column. So we need to know how to add a column vector. So the only elements in that matrix are going to be the elements over here. So let that be 10. Let the element over here be 30. So 30, and let the element over here be 70. So this is, and we have done this in the previous lecture, this is how you generate a column vector. So now if we do something like this, a new vector which we are trying to generate, a new matrix which we are trying to generate, where we are going to have the entire A plus a fourth column. We are going to do it this way. So A and B without the semicolon, because semicolon is needed only when you are entering the rows. But over here, we are basically adding this element of B on each of the rows. So you don't need the semicolon. You just need the entry of A and then the entry of B attached to it. So let's see if this works. We are going to get a new 3x4 matrix with a new fourth column. And indeed, we do get that. So these tools might come in very handy for this second homework. Okay, so one more thing that I've noted over here in the lecture note, sometimes you might, and I think you have been asked on the second homework to delete parts of matrices. So just review the previous lecture where I've tried to discuss the use of null vectors on how to delete parts of a matrix. So that would be useful for this homework. And a null matrix is like, for example, to show you what I mean. So over here, C is this, fine. So suppose we are trying to remove this second column. Okay, so how do we do that? So second column is this, and that basically covers all the rows. So all the rows, but just the second column. So 2 for that. And that is a null, because we are trying to remove that, that is a null matrix, or I call it null vector. So that's like the 2 square brackets, and press and enter. And you see that I have successfully managed to remove this second column from C. And I think you will need this in the second homework, this kind of tricks. So some of you had questions on the second homework. If what we have discussed until now, they don't help you, just shoot me more emails. Okay, so let's move on. What we have here on the lecture is a quick look at the different mathematical operations that you can do on different matrices. So of course, you can do addition and subtraction of matrices, but you can only do it if they're of the same size. Otherwise, you'll get an error. So just try out the different matrices that you have in your MATLAB. I'm not going to do this because it's trivial in the sense that, for example, we have A, and suppose we have C, or we don't have a C, so let's try, we have, I think, an A. So if I try to do A plus this small a, we do get something. And how do we get that? Because over here, it's a 3x3 matrix. On the other hand, this A is a 3x1. So the column number in A and the row number in the small a, they would match. So try to understand these 4 rules in the context of the matrix operations that you might have learned before, and you should know these operations. So as long as the sizes are consistent, it should work out. Okay, a few more things before we go into solving a problem today is this, and I think I have covered this in the last lecture as well. If you are trying to carry out a mathematical operation on each element, for example, here we have 2 vectors u and v, and we are trying to multiply u and v, but not a regular matrix multiplication. We are trying to multiply each element of u with the corresponding element in v. You do that by the use of this dot operator, and we are soon going to see how this can be really important. Again, if you are trying to divide each element of u by each element of v at the same place, you use the dot operator with the division sign. And similarly, if you are trying to exponentiate each element of u by the element in v, you use the dot operator. Okay, so this is another piece that would be handy in the sense that I plan to have on the test quick 10-point questions where I would give you some information, and I would give you multiple choices on what the output is going to be like, and you have to pick the correct one. So let's see what I mean over here. So I have this matrix X. X is row vector 1, 5, 3, 7. And we have another matrix Y, which is another row vector 0, 2, 8, 7. Now, if we do this operation here, which is K is X less than Y. It might not make any sense to you right now, but we'll see in a moment what it implies. So once we tell MATLAB that we have another K where the X should be less than Y, the way it understands this is in the form of a logical operator, in the sense that it would look at each entry of X and at each entry in Y, and it would try to figure out whether this statement that we have typed out here is true. So it's first going to compare the first element in X with the first element in Y, and then compare it to this statement. So the first element in X is 1, the first element in Y is 0. So this statement is false, right? X is indeed greater than Y and not really less. So if the statement is false, it would generate a new matrix assigned to this variable K. And if it is a false, it would enter the number 0 for that entry. Similarly, if you come to the second places, so 5 is greater than 2. So this is again false. So we get another 0 for that place. But if we now come to the third entries, here we have 3 for X and 8 for Y. So the statement is indeed true. Y is greater than the X. So if it is true, it returns a value of 1. So it's like a binary operator. False is 0, true is 1. And it assigns that number to that place in K. And then again, if we come over here both the entries are equal. So the statement is again proven to be false. So it again allots a 0 for that entry in K. So exactly that's what I have done here in all these examples. So apart from the logical operator side of this story, what you need to remember is this. So this particular symbol means that X is being compared to Y such that all the elements, if they're equal or not. And if they're not equal, then you'd get a false output. So for example, here the only equal elements were the fourth elements, and the output would be 0, 0, 0, 1, because that statement, if that element in X is equal to that element in Y is true, it's just true for the last element. What we have here is, this is another special symbol that MATLAB understands, is I don't know what it is called. Anyone can suggest what it's called? I think it's a vinculum, right? This kind of wavy symbol. Yeah, so whatever that might be called. So that and an equal sign would mean not equal or unequal in MATLAB language. So It's trying to figure out if this statement is true, in the sense that if the element in X is unequal to the corresponding element in Y. And that is true for all these elements. So 1 is being assigned to all these 3 places, but it's not true for the 4th element, where they're actually equal. So you get a 0 over there. Okay. So there would be short questions on this kind of logical operators. So make sure that you know how to understand how to interpret them. Okay. And I think I have already covered this before. So this is how you generate a vector that would be one of the building blocks to your code when you are trying to repeat your calculations. Okay. So let's now look at an example. And before we go into that example, let's take a moment and figure out the overall philosophy that we are trying to use. So for example, let's think about that code we wrote in the very first lecture, where we were trying to draw that circle. Yes, we had to know the trig functions. We had to know the mathematics, but if you remember, we also, let me see if I have that code here. Yeah. So if you look at my editor window, I have this code. So if you remember, we also needed this step where we actually assigned or actually tried to identify certain distinct values of that angle. So we picked a number of angles along the periphery to figure out the coordinates of that peripheral point using that angle. So although we did need the trigo functions, we needed this as well. So this implies that we had to tell MATLAB whatever we want in the form of an array of numbers, because if you just copy paste this, and if I type this here and press an enter, you see that it is again an array of numbers. So MATLAB always operates using arrays, and that's how it would do all the calculations. So keep that in mind as we go into actual problems. So I think that's what I try to mean over here. You should take full advantage of array operations by vectorizing your codes and computations. And by vectorizing, I imply structuring the calculation such that you can use vector or array variables with array operations, like we did in this particular case, where we actually came up with an array version of the angles and used the discrete numbers from that array to figure out the coordinates of the points on the circle's circumference. Okay, now let's look at a new example. So this is the question we have. So we have to figure out the numerical value for exponential x when x is 1. So calculate the exponential function ex with the first 10 terms in its series expansion. And some of you might know this. So exponential x can be expressed in the form of a series where it's a sum of terms, where each of the term has this form. And you can sum up to how many numbers, it doesn't really matter. Over here, I'm asking you to sum it till 10 terms. So for the first term, k is going to be 1. So x to the power of 0 divided by 0 factorial. And then x is going to be 2. So x to the power of 1 by 1 factorial, and like that. So we are going to use this given function that's given to us. And there would be similar problems later on as well, where this algebraic form would be given to you. But you need to do the numerical part of the exercise, as in how many number of terms you might want to sum up, and then set up a code accordingly. So let's see how we do that. And we are going to do it in 2 ways. Number 1 would be on the command window. So we are trying to sum 10 terms, right? And we are trying to get the exponential of 1. So the first step is to tell MATLAB that x is 1. So now x is 1. The next step is stating the range of the summation, which in this case is k 1 to 10. So k is 1 to 10. because the default is 1, we don't need to add any increment, but some cases you might have to. So we have defined k and x. Now let's look at the sum. So the command for summation on MATLAB is sum, and we type this x to the power of k minus 1 divided by factorial k minus 1 and bracket close for the sum. So let's see what we get. We get an error. Can anyone tell me why that error happened? I'm pretty sure that we copied the function correctly, but still there was an error. And why should it be?
Did you forget the periods?
No,
So
I
it would
did
affect
not.
each element?
I did not forget the periods, but I guess you are on the right track. Here we have k, as k is a collection of 10 elements, right? 1 to 10, whereas x is just 1. And we have not really told MATLAB how to do that calculation, because it's like trying to deal with apples and oranges in the same calculation. So what we instead need to do is this. And as I've been telling you, the dot operator is very important in most cases. So there should be a dot operator here where all the different k's would be implemented on that value of x individually at a time. Similarly over here, dot and dot. And now if we press enter, we get the number. So if you guys have calculators in front of you, just try to type exponential e1 and tell me what number you get.
Uh, 2.7183.
Yeah, so I think you're getting 2.7183, but 82818. So the accuracy of the number would depend on how many k terms you actually include in your calculation. So suppose if instead of k to be just 1 to 10, if we have k to 1 to 1000, and then if we do the same calculation, okay, for this one it is accurate enough, but in some cases you would see a slightly different number. But this is on the command window, and command window is probably not always very useful in terms of carrying out this kind of problem. So let's look at setting up the code for this problem. So while you set up the code, again, the first steps are clear all, close all, CLC. And once you understand the logic, you can just follow the algorithm that we have already used. So x is 1, k is equal to 1 to 10. And instead x specifying x as specifically 1, let's do input enter x, and this slash and n would take the control to the next line. We are going to come back to that later on, but let's have this over here, and then this calculation that we did. So to get the sum, to get the exponential using the series sum, exponential. And then we save this as fall 2020, lect 3, code 1. And let's run this. So as we run this, you see that MATLAB is asking me the question, enter x. So this slash n actually takes this control to the next line. Otherwise, the control would stay over here. It doesn't really affect the performance of the code, but it's just nicer this way. So x is 1 for this particular question. So I press 1, and I don't get an output because I have a semicolon here. So I have to again press E to get the number that it has calculated, and that is 2.7183. Now let's again run this code. And instead of x to be 1, let's type x as 2. And then I again press E and enter. You get the different number. So this is a much more useful version where you can actually use the same code and again to figure out the exponential for different values of x. Okay, so let's wrap up today. So this is how you calculate a determinant of a MATLAB, and I have shown the syntax over here. So if you have A to be A as a matrix, as in 1, 2, and 3, 4. We can just use dit A to figure out what is the determinant value of A. And here is a screenshot of some examples that you might find useful. We have the homework here. Again, this is due next Thursday. So both the homeworks from this week, so the one from Tuesday, the one that I had allotted on Tuesday, and the one that I have here today, both are due next Thursday at 11 a.m. And for all of you, the lab classes are starting next week. So the first lab classes, I think, are going to start from Tuesday. Just try to attend your individual section, and the TA is going to conduct the lab classes. He will send out a Zoom link like I do before the class. Feel free to ask him questions on the homework. So try to use the lab times as efficiently as you can. Okay? Any questions before you guys go? Okay, sounds good. If you have any doubts, just let me know. Spend enough time on the homework problems because they can be a little challenging. And if you have any questions, try to use the lab time and ask the TA. Okay, so have a good weekend. I'll see you guys next week.